Hello everyone and welcome. My name is Mike Ruiz. I'm a solutions architect here with AWS. And today we're going to discuss how to top media distributor had success with Cloud NAS on AWS. Today's presenters are myself, Mike Ruiz, solutions architect with Amazon Web Services, Joey Wright, senior solutions architect at SoftNAS, and Keith Sun, he's the director of infrastructure at In-Demand. The agenda is pretty straightforward. I'll start with an overview of AWS with an emphasis on AWS storage solutions. And then we'll hand it over to Joey and Keith to discuss the In-Demand success story with AWS and SoftNAS. We'll have some time near the end for Q&A. As you have questions through the session today, go ahead and put them into the questions pane in the control panel. You can also change your audio preferences there. And this, just to let you know, a download will be available 2 to 3 days after our session today. So a download of the webinar as well as the deck will be available to you. So look for that in email a couple days after the session is completed today. So what are our learning objectives? We want to learn how to prepare on-premise file storage for a cloud. Preparation and laying the groundwork is essential for success. We also want to ensure data protection and security in the AWS cloud. And we want to understand practices for petabyte scale cloud storage. So beyond gigabytes and terabytes, there are best practices that we need to consider when we scale to the petabyte level. So without further ado, let's discuss cloud storage on AWS. So what are some of the common on-premise storage challenges? I think we're all familiar with the concept that storage, adding production storage or any other type of production storage in an enterprise is a process that can take weeks or often months. In one notable case in my career, it took over a year to get storage online and active in production. We have to actively over-purchase capacity because of the timelines that we're going to use these storage solutions for. So we're often locked into 3 to 5 year depreciation schedules or long-term leases when we provision this capacity. Over-provisioning can lead to higher costs for building and maintaining the storage. Oftentimes, maintenance costs can exceed 20 to 30% of the original purchase price. In at least one case in my career, well over 100% of the original purchase price was due to maintenance, physical maintenance of the machinery, and then software maintenance of the software stack. This can be especially important when understanding issues around compliance. So oftentimes when I'm performing long-term retentions of data for compliance purposes, I'm having to maintain several stacks of hardware. This can create a higher cost environment. It's also harder just to meet our compliance objectives with being able to articulate where data is in the system at any given time and maintain that chain of authority. So how does the AWS cloud help us solve these problems? Probably the most important is that AWS provides an integrated solution. So storage solutions on AWS are integrated with the other AWS services, compute and networking. So they all work together in an integrated fashion. This is unlike other environments where I may place storage in a particular silo for a particular function. Data on AWS is also secure. It's easy using the foundational tooling to encrypt data at rest. We offer libraries for encrypting on the client side. And because we're accessing all data through a common set of APIs, we can actually tightly control access to the data as well and log who exactly is using the data and for what purpose. It's easy to maintain. Obviously, AWS is going to maintain the hardware underneath these storage services. And you're given the task of maintaining access to and what storage you want to maintain using our front-end APIs. It's scalable, so we're going to scale out to whatever size you need in our storage tiering. We also can scale in as your needs change over time. So maybe we have a monotonically increasing storage workload, we can accommodate that. But then you also want to do a test or a POC with the data. And scale out to perform the test and scale in when that's complete. All of this can lead to dramatically lower cost. You're only going to pay for what you use. And to actually use and gain access to these storage infrastructure on AWS, you're going to have a choice of 16 regions across the world. These regions are comprised of 42 availability zones. But maybe more important is the availability of edge locations. This is going to accelerate your access to data. We can cache data at the edge, and we can also cache uploads at the edge. So dramatically accelerate storage operations through the network. As mentioned, AWS Storage is a platform with a variety of different solutions to accommodate different use cases. So we have a file-based Amazon EFS product. We have a variety of block options, very flexible service called EBS, let you pick the performance profile and the size with the cost model that's going to accommodate your use case. We also have on-host instance store. So these are physically attached to EC2 instances, provide very fast access to local disk, NVMe, SSD, magnetic media, depending on your use case. And we can blend these two solutions. Amazon S3 is a service that provides access to objects that can scale out to any size, both dimensionally as you put more data and with performance as you access the data more. So Amazon S3 we often see is the data hub for an AWS deployment. Then Amazon Glacier has a similar access model that is designed for infrequently accessed data and is made available at a lower cost than S3. How can I connect to these options? Use hardware VPN, get up and running with AWS very quickly. Use your hardware VPN to connect to an AWS managed VPN connected point, and that will allow you to have private access over an encrypted tunnel to your Amazon VPC assets. So no public IP address if you don't wish. We can use Direct Connect to peer your data centers with the AWS region. It provides a high-speed, highly performant solution for customers needing a long-term relationship with very high assurances around capacity to AWS. We can do both. We can build a Direct Connect, do VPN right on top of that, so build encrypted tunnels through our private connection to Amazon AWS. And finally, we could roll our own with software VPN. Whatever you can imagine, whatever you can support today on your servers, we can build an equivalent in AWS to extend your connectivity. And with that, I'm going to hand it over to Keith and Joey. They're going to discuss how In-Demand uses AWS and SoftNAS Cloud for enterprise storage.
Thank you, Mike. I'd like to thank everyone for taking time out of their busy schedule to attend this webinar. Before I start, I would like to give you a little background about In-Demand. So we are the nation's biggest distributor of transactional content in North America. We are owned by the top multiple system operators, Comcast, Charter, and Cox Communications. We serve hundreds of multi-channel video providers across North America. We provide pay-per-view and video on-demand services, including movies from major studios and indies, boxing and UFC. We offer pro sport packages delivering 10,000 live games each year, including transport services and marketing. So a little bit about our storage challenges. So In-Demand, on-premise storage contains nearly a petabyte of data, which was becoming costly and inflexible. Our yearly maintenance cost was also increasing. We need a storage environment with greater flexibility. We needed our storage to grow as our business did. We tried to build storage using a homegrown solution with an open source file system, but it wasn't scalable. So some of our storage requirements, we needed to deploy more capacity for on-prem storage, and that could take weeks to provision. We needed a way to quickly ramp up storage capacity, and the media files we were receiving were getting larger every day. We also wanted the ability to sync between our AWS environment and our on-premise data center. So the solution we looked at, we currently use a solution consisting of AWS, SoftNAS Cloud, and Aspera product and services. Aspera servers are our high-end data transport used to ingest content and move it into our storage pools. SoftNAS Cloud stores the files and syncs down to our on-premise storage. So from the diagram, you can see that we have 2 points of ingest, one on AWS and one for on-prem that our Aspera servers use to pick up our files. On AWS, SoftNAS is a storage pool we use there to move the files from Aspera, and on-prem we use a local NAS for our storage pools. We have a 10 gig line between both storage pools to sync data between both sites. We use SoftNAS primarily files that are interested in both locations are worked on there and sent back out. But every once in a while, we need to move a file between AWS to on-prem for any kind of special encoding or processing for our different MSOs. So that's what the file sync between the two can be used for. As a result, with the help of AWS and SoftNAS, terabytes of production-ready storage are now deployed in minutes compared to weeks. Core business processes are now being moved to AWS. In-demand no longer has to wait for new hardware to come in and provision. AWS instances are pay-as-you-go, and CapEx is significantly reduced and changed to an OpEx model. Thank you, everyone. Now I'm passing over to Joey at SoftNAS.
Thanks, Keith. Thanks, everyone. We've heard a lot about some of the offerings at a high level that Amazon brings to the table with their core solution. We've talked about EFS, we've talked about EBS, we've even talked about our object storage solutions. And then we got to hear a little bit about how those solutions are being leveraged by in-demand for their particular use case. Well, what SoftNAS wants to bring to the table here is a solution, I'm not pressing any buttons there, is a solution that allows our applications to consume the modern storage that Amazon wants to deliver to us, but we want to abstract it such that your applications, as they exist right now in your on-prem environment, can consume. So what that means is we want you to be able to take your applications, move those applications immediately to the cloud, and start leveraging and consuming the modern storage offerings without having to modify your application in any way, shape, or form. And what we can do here is we can deploy a virtual appliance in minutes in the Amazon platform. We can then provision both EBS and object storage to this virtual appliance that is SoftNAS, and then your applications are able to consume up to 16 petabytes of that storage from this one virtual appliance via native file system protocols. Your standard NFS, your POSIX compliant file system, your Windows CIFS SMB shares. We can even turn that EBS storage and S3 storage into our own personal SAN with iSCSI. And for those organizations or those use cases where you have a proliferation of Macintosh machines and they want to leverage the Apple filing protocol, we even support that. But beyond all of those individual abilities to consume data, we give you the ability to bring benefit above and beyond what's natively inherent to those storage solutions or storage offerings via Amazon. We take data durability as something that is very important. We take snapshots of your data up to every hour on the hour, giving you the ability to go back in time instantly and get access to your data as it exists prior. We also abstract all the heavy lifting from you so that when you sit down to deploy this solution, it's very easy to do. You don't need any specific training to deploy SoftNAS and Amazon. And once it's deployed, you don't even need access to your AWS portal. We can handle all the management of your storage directly from our console. We give you the ability to thin provision storage. So if we have to deal with large-scale data sets, petabytes of data, we don't have to automatically consume all of that data just by provisioning that data. We can dynamically and organically grow, leveraging the cost benefits of doing so in the AWS environment. We offer inline compression and deduplication as a core component or core feature of our offering. Obviously, compression is great in this pay-as-you-go scenario because we're paying as bits go across the wire. We're paying as bits sit somewhere. So if we can reduce that transmission, if we can reduce the capacity that sits at rest, we're saving money. But an important part of just getting your data into the cloud and making that data durable is also making that data available in the event something happens. So we do offer disaster recovery and high availability solutions that build on top of what's already deployed. We can replicate in between availability zones. We can replicate, as Keith talked about, from Amazon to on-prem or on-prem to Amazon, replicate in between regions. We can get you that second set of data or that third set of data, whatever their scenario dictates, to keep your data and make your data available. If you need instantaneous access in the event you lose one of your SoftNAS systems or access to your primary storage system, we can put HA into this mix. We can give you sub 30-second failover between SoftNAS nodes so your users automatically and continuously have access to their data in the event a problem should occur. And we actually back that up with an SLA of our own. So on top of those incredible SLAs the AWS service already gives you, all of those nines built into the uptime of S3, the inherent availability of their EBS system. We extend that with our own non-downtime guarantee. If you architect appropriately using high availability within SoftNAS, we back it as well. And from a cost perspective, you get to choose whether you pay for this annually or pay for this monthly directly through your AWS subscription. And quite possibly one of the best things about this solution is its flexibility. We're coming from that on-prem world where we have to overbuy technology, overbuy capacity just to make sure that we're accommodated down the road when something might happen. Quite oftentimes, we're either buying something that is way more performant than we actually need, i.e. more expensive, or buying something that can't quite keep up. Well, because Amazon is constantly evolving and it's constantly making these changes to its storage offerings, we're able to leverage any and all of those offerings directly from one virtual appliance, from one SoftNAS device. So on this one device, we can architect a solution that meets not only the needs of our lazy data, those infrequently accessed cool data. We can leverage Amazon's S3 or cool hard disk drives for that. But on the opposite end of the spectrum, on the same device, we can provision capacity that has the high IOPS, the high throughput that certain applications or certain use cases dictate. So not only can we architect this in a flexible fashion, but we can architect this to make it the most cost-effective solution as well. And such is the nature of AWS and SoftNAS that as your needs change, as your use cases change, we can re-architect on the fly. We can generate new storage to accommodate a slower use case, etc. Those are flexibility options that we can't do in an on-prem CapEx model today. So extremely flexible, extremely fast, and extremely quick to implement. So managing storage on AWS is a great thing. We're all already familiar with the benefits of moving to cloud, and I'm assuming everybody on the phone is either in the process of doing so or knee-deep in the planning to doing so. So what we're trying to do here is we're trying to take the onus, the management, the SLA from keeping all of those extra features of our storage infrastructure online, and we're trying to put that off of their shoulders and onto the shoulders of AWS. Let's make the responsibility for uptime for the computers we're actually running on in the data centers somebody else's responsibility. So now all we need to worry about is what's important to us, those applications that keep our business running and generate revenue, and the data that actually represents what's important to us. So we can now focus on what's important to our organizations, what's important to our solution, and no longer have to account for all those hardware maintenance fees and all those forklift upgrades and what's going to happen when that lease expires on that expensive equipment. We can simply change as we need to, adapt as we need to on the fly. So our architecture on AWS is very simple. We're going to have an AMI that exists within the marketplace. You get the option to choose from a very wide degree of capacities built directly through your AWS subscription, or you get the ability to purchase an annual capacity directly from SoftNAS in the form of a BYOL license. All of those licenses give you the option to trial. So if you'd like to actually test this out, you can go and do so for 30 days free of SoftNAS subscription charges. You're on the hook for AWS infrastructure, but you're able to test these. The point is, though, we're able to stand up a single virtual appliance and attach to that virtual compliance the capacity that we've licensed for. And that capacity can be made up of any of the EBS offerings, and it can also be made up of S3 object storage, or a combination thereof. Once you configure that storage on that device, we can leverage encryption options above and beyond what Amazon provides. We can leverage in-flight encryption with some of the features of the advanced protocols. We can turn on that inline compression and deduplication if we want. We get to control our snapshotting policy to determine how far back in time we can get access to our data. And we also get to control who has access to our information. We can integrate with Active Directory if we want to use Active Directory ACLs to control who has access to our CIFS and SMB shares. We can leverage LDAP and Kerberos to control who and how people access our NFS mounts, etc. So all those features and benefits you'd expect to see from a local enterprise NAS solution are now available on a very efficient, very small infrastructure inside of AWS. So from a use case perspective, we're doing a lot of things for a lot of different people. Since we are in fact a storage provider, you can just imagine that anything that uses storage can very easily and very quickly consume SoftNAS and AWS resources. A lot of the very popular use cases are, cloud backup and archiving. A lot of people currently have a very heavy investment in these large on-prem storage area networks or NAS solutions, and they've got a lot of data on there that's really not necessarily using that infrastructure to its best purpose. So what we'd like to do, or what we'd like to propose, is let's use SoftNAS as a means to take all of that backup information, all of that archiving information, all of that lazy data, and let's relocate it to Amazon without having to worry about reformatting that data via API or rewriting something, so we can put all that data where lazy data should go on S3. From a disaster recovery perspective, we do give you the ability to replicate information. Not only do we replicate in the cloud, but we can replicate in a hybrid fashion. If you currently have everything operating on-prem, you currently have backups being taken, we can introduce a solution that puts a SoftNAS on-prem, starts replicating that information to the cloud. In the event we lose access to your primary facility, your primary storage offering, we do have a second set of data in your cloud that would permit you to spin up in the cloud, it would permit you to restore back to the cloud, etc. But it's killing two birds with one stone. Not only are we protecting you from that disaster recovery standpoint, but we're getting your data in the cloud, so when that migration to cloud services starts, when your applications are ready to move into AWS, or perhaps they're not even ready to move into AWS, but we now have the facility to allow them to run on EC2, consuming storage and writing to storage the way they're currently designed, so we could perhaps speed up your migration to cloud because your data is in fact already there. Talking about that hybrid cloud solution, it is very important because there are a lot of different scenarios and a lot of different requirements from hybrid. Not only is the scenario valid that you have a large infrastructure investment in on-prem storage, but what about those organizations that are distributed very broadly, and you have data stores located in lots of different parts of the world. Now we have a solution that allows you to start bridging these gaps by replicating data from these remote utilities or these remote offices, whatever they might be, into AWS, into a central shared repository. So again, we're taking that on-premise to cloud migration, and we're extending it beyond just a data center to cloud, but we're extending it now to branch offices, remote offices, global offices, whatever they might be. Now, for this last bullet, this software as a service enable application, this is important because everybody that's probably considering or already in the process of moving to the cloud has targeted some of those core applications that are very important to their line of business. they've targeted them for redevelopment or rewriting. They want to consume cloud the way it's meant to be. They want to consume it natively, and they're going to rewrite their applications or re-architect those applications to make best use of that infrastructure as it exists within AWS. Well, that's great, and that's ideally what we do for everything, but there are in fact applications that don't make that cut. They're pushed to the back burner. They're just sitting there. There's no funds for them. There's no resources to allocate to refactor them, etc. Well, let's take those applications that are consuming on-site resources, even if it's just real estate, electric, power, air conditioning, people to manage it. Let's take that expense, that CapEx model, and let's move it to AWS, allow that application to simply run on EC2, consume storage like it's already configured to do so, and now the SLA for keeping those things running and keeping the lights on is no longer our responsibility. So we can software as a service enable those applications that aren't necessarily targeted to be redeveloped for that process right now. We've already talked with Keith a little bit about his solution at in-demand. We do have a lot of organizations out there that are actively consuming SoftNAS in production for a lot of different solutions, not just the backup and archive scenario. We've got a use case that's quite frequent of using users in Active Directory using and writing their home drives on the S3. We've got SAP out there leveraging SoftNAS storage on the back end. We've got Oracle databases that are constantly relying on putting SoftNAS into our system. We've got a lot of people using this for a lot of different use cases across a lot of different organizations for very mission critical processes. And if you'd like to test that, definitely let us know, and we'd be happy to continue this discussion, help you evaluate SoftNAS any way we can, and if you'd like to trial or you'd like to learn more, definitely reach out. At this point, I'm going to go ahead and hand this back to Mike, and we will start our Q&A.
Okay, thanks, Joey. So thanks everyone for the questions so far. We do have quite a bit of time, so if you have any questions, let us know. And Joey, if you're ready, I think some of these questions might be best addressed by SoftNAS.
Certainly.
So I have there's a customer asking about caching on the local side or at the client, or can you comment about caching strategies for SoftNAS?
Sure. So since we are a storage controller, we have to think about caching in the context of a storage controller, not necessarily in the context of this globally distributed data orchestration that we're trying to accomplish. So caching from a SoftNAS perspective basically means we're going to store most frequently used or most recently used information on some sort of high-speed drive. So for example, if we talk about creating a large piece of capacity that's backed by S3 object storage, that object storage is performance limited. So what we can do to increase the performance, in the case of reads specifically in this example, is we could create a read cache that is made up of faster storage. It could be general SSD, it could be the ephemeral disk that come with some of our instances on EC2. Either way, we'll cache all the most frequently used and recently used data on this very high-speed storage. So as far as the reads are concerned, they happen at the speed of that storage. In the case of ephemeral drives, they happen extremely fast, faster than we can get with default offerings within EBS or S3. We also do something similar with writing, which essentially what we can do is we can augment memory. The place writes first, get committed to our system with high-speed disk, general SSD, preferred IOPS, etc., so that we're able to store more information in flight, alleviating some of the burden we place on the network, reducing some of the congestion we could cause by writing too fast to something like an S3 backend. Now, as far as being able to cache from on-premises to AWS, we do partner with other organizations, Talon being one of them, to bring edge caching, global namespace, and global file locking to the table.
Okay, great. I think we also have two questions about connectivity between on-prem and the cloud. So I made a few comments around direct connect, but I think there's some specific questions about, high speed. What does high speed mean? How fast would you recommend customers, or how would you recommend customers start to think about how to connect to AWS?
Sure. So the one limiting factor, or the primary limiting factor in any network attached storage option is going to be that network. So in order to determine what type of network we need to better understand what type of data we're dealing with and how often that data is transmitted or received. So we need to understand how much data you're sending at any given point and how much data you would expect to receive at any given point. Once we understand that, not only can we architect or select an EC2 instance that can meet those requirements with SoftNAS on it, but then we can start sizing the network required to actually make that happen to your on-prem. So it's very hard to say what is slow and what is fast because it's really dictated by you. What is your use case? And so it runs the gamut. Probably not the answer you want to hear, but that's probably the best answer. Give us a call. Let us understand your use case a little bit more. Together, SoftNAS and AWS can come up with a pretty good estimation of what you're going to need to make that happen.
Great. We have another customer here asking about integration with Lambda. So Lambda is obviously AWS serverless compute function. We can run code in the cloud using the Lambda service. I think some folks are interested in maybe an opportunity for integrating it with SoftNAS, or are you thinking about any along those lines?
So I don't have any information on any integration points with Lambda, but obviously if you're executing code, that code could reach out and touch data that's being hosted via SoftNAS, via any of those file protocols that are there. But no, I'm not aware of any integration points at this time. So if you have any ideas on where you'd see those integration points, definitely reach out and let us know. That's always something we can evaluate.
Okay, that's great. So does SoftNAS have support for encryption and deduplication?
We do. So we augment or enable encryption in this way. So when we first create SoftNAS, we have to turn those EBS disk and those S3 buckets into something our file system can understand. So that means we have to create what's called a virtual disk. When we do that, we can turn on encryption as provided by Amazon. So in other words, we're enabling disk encryption for EBS, we're enabling bucket encryption for S3. At another layer, we take those disks and we associate them to a pool, something our file system can now consume. That a pool is essentially a group of like disks. Maybe we'll have a pool for S3, a pool for general SSD, so on and so forth. At the pool level, for our block storage, we can turn on LUKS encryption. So this is Linux-provided file encryption at the pool level. Then, beyond that, if we're using NFS or SMB, we can force NFS 4 or SMB 3, we can force in-flight encryption. So the understanding or the assumption is here, in the absence of a third-party encryption solution, we can make sure you are encrypted 360 degrees from in-flight to device, leveraging not only what AWS provides, but some of SoftNAS on top of that. As far as deduplication is concerned, we do offer inline deduplication. So we're going to dedupe it as it's coming across, and it will ultimately sit in a deduped manner. That does impact our compute a little bit. Dedupe's a memory-hungry process. So one of those things, we take that into consideration when we're choosing the correct EC2 instance to build this environment on.
Okay, we have another question, I think, regarding concerning scale out. And so this customer is asking about kind of the tension or interplay between choosing a lot of mount points versus having fewer. Does SoftNAS have an opinion as you scale out use? Should you choose lots of small volumes versus relatively fewer large volumes? And then this customer also has a question on what's the maximum size? So I guess some concept around limits of the deployment in AWS.
So I'll hit the maximum size first. Our maximum limit on a single EC2 VM is 16 petabytes. Not that we'd ever recommend you do 16 petabytes right now in a single instance. But having said that, how we break up that capacity on a SoftNAS instance or a SoftNAS VM is pretty much predicated upon your use case. So we have organizations that create large monolithic volumes, and there are millions and millions of files on these large monolithic volumes. At the same time, we have other organizations that are taking large capacities and dividing them up into 1 terabyte, 10 terabyte folders that we share out via CIFS or an NFS mount. It's really dependent upon your use case. Now, as far as scaling out SoftNAS, we scale up right now. We make best use of a single instance all the way up to a 16 petabyte capacity limit. So unless you have the need to geographically disperse your data, perhaps one SoftNAS in US East and another one in Singapore, for example, then we would scale up with just one instance. So unless you have the need to disperse it geographically, we're going to scale up.
Awesome. So I think we have another question about access maybe in these distributed scenarios. So if I have 2 locations and files are accessed from 2 computers at the same time, how does SoftNAS behave? So I think this is a question about concurrent access and locking maybe across geographies.
Right. So you have to remember SoftNAS is central now. All of your data is existing centrally. So if 2 people try and access the same piece of data from the same SoftNAS machine, one of them is going to get locked out. The only time global file locking is important is when you actually have 2 copies of that data sitting somewhere, and you need to make sure that if one person opens that file from California and another person opens that file from DC, somebody is being told that it's in use. And we partner with other organizations to bring that kind of in-caching where they have the data local to them and file locking to the table.
Great. I think maybe one final question here on the list. This customer is asking about features within SoftNAS that might support a server migration to AWS. Is there some special way that you might work with customers that were SoftNAS customers to move virtual machine images?
So moving the actual VMs to EC2 is something I'm sure we could help you with a partner or locate a partner with, as would Mike and Amazon. What we do help you with, though, would be the data that that application needs to consume. So if that application that's running on those VMs is reaching out and connecting to a large CIFS share or requires a large iSCSI volume in order to function for its SQL database, etc., that's where SoftNAS would come in. So the help SoftNAS would bring would be obviously not only the vehicle to allow them to access their data, but then we could help them in the migration of that actual data, how to lift it up from on-premises and shift it into AWS. And there are various tools that we can bring to bear to make that happen. That's a conversation we can definitely have in detail if you're interested. But yes, we would help in several different areas, not only allowing that application to run and connect to data the way it's already written to do so, but in the lifting and shifting of that data into AWS.
Okay, maybe a question if we still have time here. One more question. So from your observations, and Joe, I'd like to hear your observations on this. What are the pros and cons of accessing S3 buckets with SoftNAS versus another method? I think we touched on one importantly, which that is kind of, we stay in line with on-premise practices. So whatever we're doing on-prem, we can do that in AWS. But are there any more advantages with using SoftNAS to front-end services like S3?
So the biggest advantage is not having to write your application to read and write via API. They can consume it natively via file access. So that's it first and foremost, or that's the biggest benefit, allowing us to consume object storage. As far as the cons, there aren't really any cons, but there are considerations. You always need to be cognizant that S3 is a performance limited infrastructure, and we need to make sure that if we're going to leverage S3, that it's going to meet the requirements of your particular use case. To give you a wild example, we're not going to put any transactional databases on S3 by any stretch of the imagination. But if we're able to operate within the boundaries of what S3 offers, it's a great solution for keeping your data, large capacities of your data out there in a cost-effective manner.
Great. I keep saying we're at the last question, but then this great question came in. So we will close with this one. Would it be right, Joey, do you think of SoftNAS as a converged storage solution in cloud? Would that be the right way to characterize your application? Or?
I guess it is a way to characterize our application or our solution as it exists within cloud. Right now we are focusing on getting you access to your data on the modern offerings of AWS, and that's going to morph into more data orchestration as the product matures and progresses in its life cycle. So you could definitely view us as in a way, a converged storage option for AWS.
Okay. Well, that was an awesome question. And the follow-on was just about features. You support NAS functionality within AWS, and you also provide SAN. I think you mentioned you provide an iSCSI target.
Correct.
Okay. Awesome. So block and file level access using your services. So thanks everyone for attending today. As mentioned, we'll send out an email with a recording of the content as well as the decks that we used. We'll send that in 2 to 3 days. Also, please stick around if you can and fill out the survey at the end. We really appreciate your time today. Thanks so much for joining.